So what is the role of CAD and PMI within feature-based manufacturing? Because this is very, very important. We don't want to be controlling this data in manufacturing. This is not a manufacturing data control area. We want to apply processes for features that our CAD department gives us. So if we go through and we teach these attributes to the system, that's fine because we're teaching a direct feature from the CAD department. But we don't want to alter that in any way because we're not going off the design intent. So what we can do is we can have CAD give us specifics. We can have them start applying surface finishing to things. We can have, say, a 10 millimeter H7 hole, which is modeled nominal to 10 millimeter. We could also have 10 millimeter holes all throughout the part that are just 10 millimeter holes. And feature-based manufacturing will be able to distinguish between the two because of either the H7 tolerance or a surface finish or a color or any other type of attribute that changes it from the other. I just ran into this with a customer just the other day where their CAD department was designing everything nominal, not by tolerance, not bilateral. So when he tried to do feature-based manufacturing, there was nothing to distinguish anything from a 10 millimeter dowel hole to a 10 millimeter slip fit to just a 10 millimeter through hole. So without there being some type of characteristic that's different, feature-based manufacturing is not going to be able to pick them up from one another. So one rule of thumb is as many attributes as we can get on the feature, the better off we are because we'll be able to apply them directly to feature-based manufacturing. So now with PMI, what does PMI stand for? Product Manufacturing Information. So when they start applying different PMIs on it, dimensioning, GD&T, we can utilize every single one of those attributes to drive logic through to the part. So if the part has distinct attributes that identify the feature, it's easier to develop specific machining practices for it. And what I just explained, a lot of times you get into features that look identical, have identical attributes, but may need a cleaner finish or maybe a sized hole or may have geometric tolerancing and dimensioning to it that we have to drive a different cutting strategy to. And if we have PMI data on the part, then we can easily distinguish between the two and set parameters and operations specific to that. Now, one thing I did want to mention too is the use of feature-based manufacturing out of the box without the authoring license is still a very valid tool. Me personally, when I am doing contract programming for Saratech, I don't care if I'm programming a fan blade for an air or a 360 Airbus or something. I always start with feature-based manufacturing because it derives all of my geometries for me, all of my holes, all of my everything that I would have to manually do before it creates for me. So at least I have 50% of my upfront work done for me. So, and I very rarely teach processes into the knowledge editor for contract work because it's singular, but I still use feature-based manufacturing for the upfront part. So even if you don't want to use the create feature processes, it's still a very good idea to start with feature-based manufacturing, especially when you're doing 2.5D work, because it will find those features for you and it will at least give you something to use. Maybe not 50%, maybe it's only 25% of your operation will be completed for you. So anything that we can do to get you to streamline your programming would be benefit.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.